Hello, my lovely Algebra 2 students. This is Mr. Bear bringing you Skill 2 guided notes on transformations of functions. If you haven't already done so, it will be very helpful if you pull up the website desmos.com. You'll see I have that opened up in this tab. Additionally, you will probably want to print these notes if you have access to a printer. If not, then just make sure when you're sketching them in your notebook that you are very careful. All right, so today's lesson is going to build off of our parent functions lesson. We're going to look at what happens when we transform those parent functions using a variety of transformations. All right, so the first transformation we're going to look at is what happens when we add or subtract a constant to a function. Okay, so if I look at letter A, you'll see that I have actually A, B, C, and D. You'll notice that each one of these functions is one of our parent functions plus or minus some number, okay? So what I am going to do is I am going to graph these functions, and I'm going to take note of what happens when we add a 2 or subtract a 3 or add a 4 and so on and so forth. All right, so we're going to see what happens when we add or subtract some k value, which is a constant, to the graph. Okay, so y equals x squared plus 2. I will start by drawing the parent function. Parent function is a quadratic. The x squared part, we should know that means quadratic. The parent function says that we would have a graph that looks like this. But I want to know, well, what happens when we add 2 to that function? What's going to happen? So what I'm going to do is I'm going to explore using Desmos. I'm going to type in y equals x squared plus 2. So in Desmos, you just type in y equals x squared plus 2. And you can see it retains the same shape. It's just that we've shifted it up from the origin to the ordered pair 0, 2. So what happens is I now have a vertex at 0, 2, but everything else about the graph is essentially the same. Okay. Now for the next one, we have absolute value of x minus 3. Absolute value of x, you may remember, takes on more of a V shape. That's the parent function. And so now I want to see, well, what happens when we subtract 3? When I try to do absolute value equations on Desmos, I need to type in this phrase ABS to mean absolute value. So watch how I do that. Y equals absolute value of x. And I believe it said minus 3. Yes, minus 3. And if you look here, you can see that the vertex shifted down to negative 3. So what happened now is that our graph will look the same. It's just going to be shifted down to negative 3 for a vertex point, and it'll look as such. Okay. The next one, square root of x plus 4. Well, we'll put the square root of x on here first. Square root of x kind of started at the origin and kind of curved off to the right. That's our parent function. Square root of x when I add 4 to that. Oh, by the way, when you're typing square root of x, use SQRT to mean square root. And then plus 4. And you'll see that we shift it up 4 units from the origin. So when I graph this, I'm just going to take my original graph and I'm going to shift it up 4 units. And everything else looked the same. Some of you may already be noticing a pattern here, but I'm going to show you what happens when we look at the last one, just so that we can refine our pattern. Before I actually graph the parent or the function given, I want to graph the parent function, y equals 2 to the x. This was our exponential function. And notice that its y-intercept is at 0, 1. And so it kind of curved down towards the x-axis on the left side. And on the right side, it shoots off to positive infinity. So I'm going to graph this parent function The parent function has a y-intercept of 1 and kind of graphs like this. That's the parent. Now, when I apply the transformation to it, minus 2, let's see what happens. So if I take this function, let me just type it in again. Notice this time that it doesn't have a y-intercept at -2, if that's what you were predicting was what happens. But notice that we had this ordered pair +1, and now this is -1. So we went down 2 units. Let me make this ever more apparent. There we go. So we were at +1 and we went down to -1. So we went down 1, 2 units. It might be easier if I zoom out so you can see. There we go. So you can see we still shifted down 2 units. All right, but we shifted down 2 units from our y-intercept. So I want to make sure that I point that out. And on these exponentials, this would have been our new boundary line. We'll talk more about those later in the semester. All right, so looking at what we have here, we can see now that the number at the end tells us that we're going to shift the graph up or down that many units, okay? So plus k shifts graph up. Anytime we had a plus something, the graph moved up. And if we had a minus k, such as in example B and example D, it shifts the graph down k units. And so that's what happens when you have a number being added or subtracted to a function. So look for it at the end. All right, let's talk about what happens when that k value is added or subtracted to the x value. So looking inside the functions, okay, I'm going to draw the parent functions a little more quickly here. I'm going to go ahead and draw them for each one. This first one, it's a quadratic, so the parent function is going to look like this. The next one's an absolute value function, so it's going to be the V shape. The next one is the square root function. The last one is that exponential function. Notice it has a y-intercept at 1. Now I want to show what happens when we type in the equations as we see them, okay? So I've drawn the parent functions. I'm going to do this a little more quickly. So now I have x minus 3 squared. The graph, you'll notice, shifts to the right 3 units. Okay, so the graph goes to the right 3 units. For absolute value of x plus 4, remember we type in ABS. And notice that the graph shifted over to -4. So we went left 4 units. And I know you're thinking, oh, these don't do the same thing the other ones did. Next one, square root of x minus 2. Notice the graph shifts to +2, so it goes to the right 2. And the last one, we have 2 to the power of x plus 3. And notice that our y-intercept, which normally would have been at 1, shifted to the left 3 spots. Okay? So looking at our graph, that point now goes to the left 3 spots and graphs as such. So generally, I think you can see that the k value is going to shift the graph left or right. But notice that we had minus 3 here, but we shifted right 3. We had plus 4 here, we shifted left 4. We had minus 2 here, we shifted right 2. And we had plus 3 here, but we shifted left 3. So a plus k shifts left k units, and a minus k shifts right k units. Now this type of transformation is the tricky one. I always like to call them the weird ones because they do the opposite of what we think. But we know what it means to have a 0 at a particular value, and so that's kind of how I get students to remember what these do. We can find the 0 of each one of these things by just taking this part and setting it equal to 0. If I solve that out, I get x equals 3, and you can see now that's why it goes right 3. X plus 4 equals 0 when x equals negative 4, so we shift left 4. X minus 2 equals 0 when x equals 2, so we're shifting to the right. And here this x plus 3 equals 0 when x equals negative 3. So solving those out, we'll see that if we think of those as finding the zeros of each one of those, that will allow us to then understand why those are actually the weird ones and why they do the opposite of what we would think they should do. Okay, and we will do lots of practice with that. By the time that we have practiced this, you will be at a point where it all comes together for you, okay? All right, the last thing that we're going to look at is what happens when there is a negative multiplied to the function. So I'm going to start by drawing our parent functions. These are different parent functions than what we saw in the last set. For x cubed, remember x cubed, it's a cubic function. It kind of graphs like this. Absolute value of x, that one we should be familiar with. Next one, the square root function, again, should be familiar with. And x squared, we definitely should be familiar with that. We spent a lot of time last semester graphing parabolas. So now what happens when we put a negative in the front? Okay, so negative x cubed. Oh, interesting. It just starts high and graphs low. So it's kind of like what was down below flipped up, and what was flipped up before will flip down. Okay. For negative absolute value of x, notice the graph just flipped downward. For negative square root of x, it just flips downward again. And you're probably predicting what will happen when you put a negative in front of x squared. Yep, the parabola just flips downward. Now, I'm using the phrase flip downward, but what I want you to do is really understand that we're making a reflection over the horizontal axis, which means that we are making a reflection over the x-axis. So reflection over the x-axis. The phrase I use is it flips vertically, but just know that that is not the mathematical way to say that. All right, so now we have explored the three transformations. So now to summarize it, we're just going to use this little chart here. I have a function plus k, that means we go up k. A function minus k means I go down k. A function where I add k to the x means we go left k, so that's a weird one. A function where I subtract the k from the x, another weird one. We go right k. And a negative in front of the x means we reflect or flip down. Or sorry, I should have said reflect over x-axis. Sorry, I should have been more specific. All right, and so in class, what we're going to do is we are going to apply these transformations to various functions and also know how to graph a function when there is a combination of these particular transformations. So join us for class, and we will talk more about this then.